So let's choose. So we are still in 4.4, and today is the 22nd. So still in 4.4 and log equations. So they are on page 515 from 49 through 92, 515. Yeah, because there are a lot of different situations to possibly look at.
Did we already do 65?
Which one?
65.
65, perfect.
Square, yeah, I don't think we did one with a square root in it.
Very good. So let's look at 65. So natural log of the square root of x plus 3 equals 1. Very good. So a quick refresher. What type of equation is this?
It's we can use square roots, taking the square roots, right, to solve it.
Square.
Yeah.
But now, if that's the case, if I only see this, then I have to write that x plus 3 is greater than or equal to 0. We know that. The square root will not exist if this number is negative. So all this number has to be greater than or equal to 0, otherwise the square root is not a real number, correct?
Yes.
But now I have this in front. This changes this slightly. Remember, the graph of natural log is this, which means there is a vertical asymptote at 0. I cannot have equal to 0. So this is now correct, only because of the natural log in front. So therefore, yes, so therefore the domain of this function is -3 to infinity. So I know now that I'm ready to solve it, and if I don't get solutions that are greater than -3, I will say, sorry, there are no solutions. So let's see what we do. This is equivalent to an exponential equation. But what is the base here? I don't see the base. In case you, exactly, in case you ever forget, look here, the natural log ln and base e are on the same key because they're inverses of each other. Also, log and 10 to the x, they are on the same key because they are inverses of each other. So in case you forget what is the base of log, you will know it's 10. In case you forget what is the base of ln, you know it's e. Good. So now e raised to this power, which is 1, equals the square root of x plus 3. So now the log equation became a square root, a radical equation. And we know from a long time ago that we have to square both sides to eliminate. We are using the inverse function. We are eliminating the square root by squaring both sides, and this is e squared equals x plus 3, and obviously x equals e squared minus 3. And you could say, but is this a number greater than -3? Of course it is. In case you have doubts, you can plug it in. For practice, let's do that. So second and e to the x, and put power 2 on it. You know me, in parentheses. And then minus 3. This is roughly 9 minus 3 or 8 something minus 3. Should be something like 5-ish. 4.39. So obviously, this is a yes. Why? Because it's a number greater than -3. So the answer is acceptable.
And so x equals e squared minus 3 is the whole answer, right?
Is
So
the whole answer, and that's the exact. Now, if you want to approximate, again, you can approximate it as 4.3891. If you
and
want.
when you approximate, should you always do it to the thousand?
No. There are certain situations like what we're going to study in 4.5 when we look at word problems for the growth rate and decay rate. Yes, we want 4 decimal digits, but here it's not that important. It's not, unless it has a meaning, a real life situation, then I would.
It doesn't matter, all right.
Right. Good, so let's choose something else.
So we've gotten,
This was 65.
trying to see if I can cover each one so when I come across it and
Yes.
I'm working on the test,
Of course.
I know what to do when I see it.
Yes, of course. That's exactly what we should do. We should use the time. I'm not going to give them the benefit of the doubt forever. We are down to 6 meetings, so I'm going to email them and say, please. Okay, so let's choose.
And you said it went to,
All the way to 92. 49 through 92. All the way to the bottom of the page. We have to look at condensing ones. We have to look at the ones with minus, the one with plus.
can we do 90?
Very good. So let's continue with 90. Where are you, 90? I see it. Log base 2 of x minus 1 minus log base 2 of x plus 3 equals log base 2 of 1 over x. Good pick. Perfect. So now I have 3 functions of log, 1, 2, 3. They all are functions because they have x in them. So obviously x minus 1, for the first one to exist, must be greater than 0. For the second one, what do I have to write? That x plus 3 has to be
Greater than?
very good. And then for the last one, 1 over x greater than 0. So let's see how we analyze all these. So for the first one, I have greater than 1. For the second one, I have greater than negative 3. And let's analyze for the last one. The numerator is a positive number. It's 1. What type of number should the denominator be for this quantity to be positive?
A positive number.
Very good. That's all I need. There is no other way. If the numerator is always positive, for the entire fraction to be positive, the denominator must be positive. Very good. Awesome. So now in order to see the common domain or find the common domain, I will do this. You don't have to. If you see it, I just need to explain. Okay, so greater than 1 is this. Greater than 0 is this. And greater than negative 3 is this. I have to find the common elements. So what is the common domain then?
1 to infinity.
Very good. So if the solution is not between 1 and infinity, I'll say no way, sorry, it's not. It has no solutions. Okay. At this point, after I establish this, I need to condense the left-hand side. How do I condense the left-hand side?
They divide each other, right? Because there's the negative.
Yes. In other words, is log base 2 of the ratio. So this is applied to a ratio, which is x minus 1 over x plus 3. The right-hand side is log base 2 of 1 over x. Perfect. Now, forget about this problem for a moment. 1 second. Do you remember when we looked at 2 to the x equals 2 and we said both sides have the same base? Then obviously x must equal 1. If the two numbers are equal and they have the same base, then the exponents have to be the same. Agreed?
Yes.
Perfect. Same concept. Two numbers are equal. They are logging the same base. What has to happen to these expressions? So really my question is, log base 2 of 10, can it equal log base 2 of 5? Like here, 2 to the 5th can equal 2 to the 1st?
You have to set it up where you would do to figure out what x equals, right?
Right. So, but can I say that 2 to the 3rd equals 2 to the 1st? 2 to the 3rd equals 2 to the 1st? No.
No.
Can I say that 2 to 0 equals 2?
No.
No. So I only have to say that x equals 1. In the same way, I have two logs, they are equal, they're in the same base. What do you think happens to these two expressions for them to be equal to each other? They must be equal to each other, right?
Yeah.
Because I can't have here 5 and here 10. Because log base 2 of 5 will not equal log base 2 of 10. I can have here 15 and here 2. Because log base 2 of 15 cannot equal log base 2 of 2. So if two logs are equal and they have the same base, these expressions have to be the same. Otherwise the left will not equal the right. Does it make sense?
Yes.
Yeah.
Perfect. So now what type of equation are we looking at? Once we identify it correctly, we will remember how to solve it. What type? It is a
Rational.
very good. And furthermore, it's a proportion. What do we do in a proportion? Always. And yes, you can say, wait a minute, x cannot be 0. Yes, it's not 0. You can say x cannot be -3. Yes, it's not. So you don't have to state those restrictions again because we already took care of that. So what do we do in a proportion and only in a proportion? We cross multiply. So x times this equals x plus 3 times 1. Are we okay with this so far? So therefore, x squared minus x minus 3 equals 0. Or x squared minus 2x minus 3 equals 0. So how do we continue? Any suggestions? We really hope that this is factorable.
Say factoring.
Yes, perfect. And how is it? How do we factor it?
2 and 1.
Careful, the product is -3. So x minus 3 and x plus 1. Let's try. X squared positive x minus 3x is negative 2x and negative 3. So then there are two options, and they come with a big question mark. How come? Why the question mark?
Because they have to fit within the domain.
Correct. They have to be to the right hand side of 1 or greater than 1. Are they?
3 is.
Yes.
X equals 3 is.
Yes. The other one is a solution of this, but not of the original problem. Very good pick. Let's pick the next. Yep.
Your turn, Larson.
Alright. Alright, I personally don't have the textbook open right now. I've just been...
That's okay, I can choose for you if you want. I would like to choose 79. And then Tara will choose again. In 79 we have log 3x minus 3 equals log x plus 1 and plus log 4. I'm checking 3x minus 3, yes, log x plus 1, yes, plus log 4, correct. Good, so we see two functions. This is a number. I'm not going to state a restriction on a number, but I have to state a restriction for each function before I condense. So what is the restriction on the first function? What do I have to write?
Um, 3x minus 3 is greater than 0.
Excellent. And?
X plus 1 is greater than 0.
Very good. So then 3x greater than 3 or x greater than 1. And this one is greater than negative 1. Now we can picture on the real lines. It's easier for me to explain how we choose the common domain. So the first one is greater than 1. The other one is greater than negative 1. So obviously I should stop graphing at some point in time because I think we are getting the idea. So what is the common domain then?
If it's greater than 1, then we don't have to worry about it being greater than negative 1, so just 1 to infinity.
That's it.
I suppose.
Awesome. Great answer. Thank you. Good. The left-hand side, I'm going to leave it alone. But I have to condense the right-hand side. How do we condense the right-hand side?
It's multiplication. No, what?
Yes, indeed. Absolutely. Because it's the sum. It's the sum. It's the sum of two logs, indeed. So it's log of x plus 1 times 4. Great job. What happens next? Where do we go from here? Do we need to change it into an exponential equation, or we can go ahead and say, we know what has to happen?
Since both it has the same base, we would set 3x minus 3 equal to the x. Wait, do we have to distribute the 4 on the x plus 1?
Yes, we will multiply. Exactly. Awesome. This is the correct answer. Very good. I want x on one side and no x on the other. So negative x equals 7. How much is x? X equals
-7.
And then what do we conclude?
No solution.
Excellent. Indeed, this equation has no solutions. Very good. Next question. Anything else?